Good morning, class. Today we're going to be looking at changing mixed numbers into improper fractions. Can I kindly have the date, the title and the margin down in your books, please? And then would you have a go at this starter? It asks you to take the last four numbers from your phone number. If you can't think of those, just use any four numbers. What I want you to do is write down the biggest number you can get from those four numbers. I'd like you to write down the smallest number you can get from those four numbers. And finally, I'd like you to write down as many different numbers as you can get from those four numbers. You got 4 minutes, off you go. Let's imagine I chose the numbers 1, 2, 3 and 4. If I wanted the biggest number possible, I would start from the biggest out of those four digits and put it first, I then put the next biggest number, then the next biggest, and finally the least biggest at the end. I do it the opposite way round if I wanted the smallest number, so I would just have to reverse those digits. And finally, when you're looking for as many different 4-number combinations as you can, you will find that the most you can come up with is 16 combinations. Last lesson we were looking at simplifying fractions and also changing top-heavy fractions into mixed numbers. When we simplified a fraction, one way to do it was to find a times table with 5 and 10 in this case a 5 times table, and then you would say 5 times what makes the first top number, in this case 1, 5 times what makes the bottom number, in this case 2. Likewise, if I had 3 over 12, I'd look for the times table with 3 and 12 in this case 3, I would say 3 times what makes the top number, and 3 times what makes the bottom number. I could very easily also do the following. Knowing that 5 and 10 are in the 5 times table, I could divide the top and the bottom numbers by 5, and again I'd end up with 1 over 2. And knowing that 3 and 12 were in the 3 times table, I could divide the top and the bottom numbers by 3, giving me the 1/4. When it comes to looking at top-heavy fractions or improper fractions and wanting to change them into mixed numbers, I could do the following. 5 out of 2 means I need to take my bars and split them in half, which I've done on the right hand side. I then need to colour in 5 halves, 1 half, 2 halves, 3 halves, 4 halves, 5 halves. If I look there, I've got 1 whole bar plus another whole bar, so that's 2 whole bars, and I've got 1/2 a bar left over. For my bottom one, 4 over 3, I take my bar and split it into 3 bits, and I want 4 of those. So I've got 1, 2, 3 thirds, plus another one makes 4 thirds. So that's 1 whole bar and 1/3 of a bar, giving me 1 1/3. Now for today's work, we're taking 2 1/2. This is a mixed fraction because it's got a whole number, the 2, and it's got a fraction here, the half, stuck together. Our challenge now is to write that as an improper or a top-heavy fraction. One way I could do this is by knocking out my bars again. Because I'm looking at halves in them, this bit here, that means I need to split my bars into 2, and I would do the following. This would be for my first number up here, and this would be for my second bar up here, and finally this one here would be for my half, which is my fraction over here, the 1/2 there. If I count up all of the bits that I've got in total 1, 2, 3, 4, 5 halves. So there we go, 5 over 2. Now there is another way I can get there. I could say the following. I've got 2 full bars here of halves. So 2 lots of 2 bars. So I could times these 2 numbers together. The bottom 2 and the big 2 times together would give me my 4 there. And then I could add it to the 1, which would be this one over here. In total, that would give me my 5, and the bottom number remains the same. So this 2 and this 2 remains the same. So it's just left as 5 over 2. That's a quicker method and involves less drawing than you might otherwise need. Let's have a look at the next one. Here I've got 3 and 4/5. So each bar is split into fifths. I want 3 whole bars and I want 4/5, 1 whole bar, 2 whole bars, 3 whole bars, and 4 out of the 5 bars for the last one. I could count them all up and I could end up with 19/5. I could also do the following to get there. I could times the bottom two numbers together, so the 5 times the 3 makes the 15, and then I could add that number to the 4, so 15 add 4 makes 19, and I can see my 19 at the top here. I can also see that my bottom numbers here have remained the same. That would give me 19/5 with very little drawing and gets there quickly. Okay, give yourself 2 minutes just to have a go at trying to complete these. So let's have a quick look at how these work out then. The 3 times the 4 gives me 12, plus the 2 makes me up to 14. So my top number becomes 14 and it goes back over the original 3. My second one, the 4 times the 7 is 28, plus the 1 makes me up to 29. And that goes back over the original 4. For my last one, the 9 times the 1 gives me 9, plus the 2 gives me 11/9. Okay, give yourself a minute, no more, just to get yourself up to date. Thank you. Okay, you've got 6 minutes on this. I'd like you to change the mixed fractions to improper fractions. Okay, let's have a go checking our answers. And let me just pull off a couple just to double check that everything's still good. Let's have a look at question 4. If I times together the bottom two numbers, the 7 times the 2 is 14, plus the extra 4, that makes 18, which I can see up at the top here. And then it goes back over the 7. Let's just have a look at another one. Let's try this last one. The 5 times by the 10 is 50, plus the 3, that gives me my 53. And likewise again, the bottom numbers remain the same. Give you just a minute just to finish checking on those. Okay, we're going to look now at adding fractions with the same denominators. Now that keyword denominator means the bottom number of the fraction is going to be the same. So you might have something like 1/8 added to 3/8, where the bottom number in each of these cases is 8. It will make the maths quite straightforward. But what I like now is for you to underline your last bit of work, and could you add in just this new title here, please? Remember, I need the title underlined as well. Thank you very much. Okay, back to my bars of chocolate that I used when I was simplifying. Once again, if I split the chocolate into its, in this case, 3 parts, hopefully we can remember that each one of those bits of chocolate are 1/3. Now, if I've got one of the thirds over here and I've got another one here, in total I can say I've got 2/3. And in essence, that's what we're doing when we're adding. We're counting up how many bits of those fractions we have. On my next one, I've split them all up into 8ths. Now, here is an 8th. Underneath that, there's another 8th. There's an 8th over here. So each one of those are 8ths. Now, if I had an 8th plus an 8th plus another 8th plus another 8th, right, the fraction would look like this. Like so. But I've got 1, 2, 3, 4. I've got in total 4 8ths. Now people, what you're seeing when you're doing this is that the bottom numbers here, they kind of remain the same, whereas the top numbers all get added together. And that seems to be a feature of this type of way of adding. Now bear in mind, you're just counting up how many 8ths that you have, and that's why we appear to have the 4 8ths there. If you're feeling on form, you might also be able to look at the 4 8ths and go, hang on there, last lesson we learnt about simplifying fractions. 4 and 8 are both in the 4 times table. So there's an extra bit of work here you can do. You can say, well, wait there, that's equal to, they're both in the 4 times table. 4 times 1 makes this 4. 4 times 2 makes this 8. Or if you're feeling pretty good with your dividing, then please do this. Divide the top and the bottom by the 4, and we get to that. Now the bit in blue is simplifying, and it's something you're expected to do at the end of each sum if you can. But for the majority of what we're looking at doing, the bit in red is the thing I'm trying to focus on just for now. Okay, so we've got 2 sevenths plus the 3 sevenths. So imagine you had a pizza and you divided it into 7 bits, and you gave somebody 2 sevenths and someone else got 3 sevenths. In total, there's 5 sevenths there to be counted, and that's what we get. Let's have a look at our next one. This time round, we're going to have 5/8 plus 7/8. So following the same pattern that I have from the top one, the bottom number is going to be 8, and the top number is going to be 5 add 7, which makes 12. As your judge, could you give yourself no more than a minute and a half to get that down, please? "15 more seconds. Five, 4, 3, 2, 1, and 0. Now what I want you to think about is that 12/8. That's the top heavy fraction, an improper fraction. So if you drew out a bar and split it into 8 bars, what would happen, or 8 pieces, is that you would need 2 bars in total to get up to 12/8. And maybe I can quickly show you what that would look like. 1 bar, the 4, that's into 8 bits. Now, if I coloured in each one of those, 1, 2, 3, 4, 5, 6, 7, 8, that gets me 8/8, but I want to get 12/8, so I'd better get another bar drawn in. Again, I'll split that into 8 pieces as best as I can, like so. So I'm up to 8/8, that's 9/8, that's 10/8, that's 11/8, that's 12/8. So my bottom bar, I've got 4/8 there. So I've got 1 full bar at the top, and I've got 4/8 on the bottom. So I could write the following, that 12/8 needs to change into 1 4/8. Could you please just add that to your last line of working out? Now for your final step, for those of you feeling particularly awesome, you'll be looking at that 4/8 and you'll be going, but hang on there a minute, both of those are in the 4 times table. So if I took the 4 times table and said, well, where does 4 occur? It's the first number in there, so 4 times 1 makes the top 4, and 4, sorry about that. Let's try again. 4 times 1 makes the top number, and again, because we know 4 and 8 are in our 4 times table, 4 times 2 makes the bottom 8. Or if you like your division, if you divide the top and bottom by 4, you'll get there straight away as well. So we would expect to see our 4/8 be simplified to a half. Would you mind writing that down at the end of your sum? So you should have your 12/8 is equal to 1 and 4/8, and that's equal to 1.5. Our last one was tricky. Right, people, I'd like to give you, on our next bit of sums, there's 8 sums there. May I give you 5 minutes, please, to try and work those ones out. Okay, people, mark your work, record your score, please, and then in a minute I'll go through some of those mixed numbers at the bottom. In other words, questions 5, 6, 7, and 8. Five, 4, 3, 2, 1, and 0. Okay, let's have a look at a couple of these. If I look at question 7, if I do the 7 over the 11 and I add that to the 6 over the 11, well, I say my bottom number is still going to remain out of 11. The top number, the 7 add the 6, becomes 13. So that becomes 13 over 11. So now if I had a look at my bars, one bar I would split into 11 pieces, so I'd have 11 there. On my second bar, let's put that 11 out of 11. I still want to get up to 13 11s, so I must have 2 11s in that bar to make me up to 13 11s. So I see I've got one full bar and 2 11s. Let me try a slightly thicker pen. Let's have a look at question 8. So I take my 7/10 like that, and I add it to the 5/10 like so. Let's have a look. The top line, 7 add 5 gives me 12. So that's my 12 on the top, and I'm counting how many tenths I've got. So I've now got 12 over 10. I can see that that's the top heavy or an improper fraction. So let's just have a look now at my bars. On my first bar, I would divide that into 10 pieces and I would have 10 tenths, but I want to get up to 12 tenths, so I need another bar there, like so. And in that bar, out of my tenths, I need to have another 2 tenths, because 10 tenths plus 2 tenths will give me 12 tenths. So that will be 2 over 10, like so. So writing that as my final answer, I would say I have one full bar, that's this one here, and on my next bar, I've used up 2 out of the 10 pieces there, giving me 1 and 2 tenths. But look, the answer here is 1 1/5. And the reason that happens, I have to go around this way. The reason that happens is I can cancel 2 and 10 because they're both in the 2 times table. And if I divide the top and bottom by 2, I would end up with the 1 1/5. Okay, one more to have a look at then, people. That's going to be to do with subtracting fractions. So let's start again with my bars of chocolate. Here's a third, 1 out of 3 pieces, 1 out of 3 pieces. Now we've already said that if I take those two like that, that's the same as 2/3. And if I want to take one of the thirds away from there, well, if that third was taken away like so, I would just be left with this one. In other words, 1/3. So you can think again back to the pizza analogy. If you had the following sum, Should do this in purple. Like so. If you were holding 3/5 of a pizza, so a pizza's been divided into 5 parts and you've got 3 of them, and you give away 2 of them, 2 of those fifths are taken away from you, then apart from you looking a bit miffed, you'd only be left with 1/5 of the pizza. Okay, let's have a look at doing some subtraction sums. Okay, you've got 5 minutes to work on the following. Okay, grab your pens and check your answers. Note this one here. 3/4 take away 3/4. You might be tempted to write the answer as 0/4. You would still get the mark for that. But when you've got no quarters there, that is just the same as saying it's 0. Okay, well done ladies and gents. Could you put a score for today's work? Remain seated and pack away. And then could you wait for your teacher to dismiss you? Thank you very much and goodbye.